Making this lesson for Year 11 chemistry learners. One of the most important topics in Year 11 chemistry curriculum is redox reactions, and one of the most important techniques is how to balance a redox reaction. Now I'm choosing this reaction to do this lesson simply because it looks weird. Now, before we actually do the problem solving, I would like to go through the essential techniques or the steps that we need to take to balance such a redox reaction, okay? Now, first of all, we need to separate a given equation into two half equations, right? Half equations. And the second step is we're going to balance each half equation. Now, students have to be very clear about what steps to take, and then it has to be following a certain order. Now, basically, if we look at each half equation, we're looking at the element other than H and O. Alright, so if you look at the elements involved in this reaction over here, we have chlorine, we have oxygen, we have two elements only. So basically, once we are going for the half equations, we need to be very careful with how many moles of chlorine involved in the reaction, okay? And then we're going to balance oxygen, and then we're going to balance the number of hydrogen atoms on two sides. And then we also need to consider the electrons. Alright? And finally, we're going to add the two already balanced half equations together, and we're going to do some simplification. Alright? So to illustrate these steps, I'm going to write this equation on this side of the board to show how each step is completed. Alright? So we have chlorine, O3, and then we have chlorine ion, and then we have ClO2 over here. Right? So we have these things. Now, actually, people might get very confused, and then we get stuck at the very first step. How to break this down into two half equations. Now, if you look at the number of reactants and products, we have two reactants on the left side. Apparently, each of them belongs to one half equation, right? But on the right side of the equation, we have only one compound, which is the only product we have. Now, once we get to this stage, where should I put this compound? Do I place it in half equation A, or do I place it in half equation B? It is a very common question raised by students every year. But at this stage, please don't panic, right? Actually, the reason why we have only one compound as the only product is simply that a few moles of this compound is coming out of a reduction process. Some moles of the same compound are resulted from the oxidation process. So actually, the two half equations would be grouping one of the reactants on the left side and the product on the right side. Apparently, the other half equation would be the chlorine ion with the ClO2 on the right side. All right. Now, I'm using the first half equation to show how these steps are completed. So, what's our first step? The element other than H and O. Now, the only element other than H and O is chlorine at this stage. We have one chlorine on the left side, we have the other chlorine on the right side. So 1 and 1 is already balanced. So there's no need to add any coefficients in front of the two compounds. The second step is to look at the oxygen. We have 3 oxygen on the left side, we have 2 oxygen on the right side, and then the two numbers are not equal, so this step is essential. Now, if you can recall how to balance the oxygen numbers on the two sides, it is by adding H2O. Alright, H2O is the source of oxygen atoms in this case. So we have 3 oxygen on the left, 2 on the right. Apparently, I need to add one oxygen on the right side, but I cannot simply add one atomic oxygen. I have to add H2O. Now we have 3 oxygen atoms on 2 sides. It's already balanced at this stage. Now moving on to the next step. The next step is looking at the hydrogen. Because originally there was no hydrogen atoms playing in this reaction, but since we have added one water on the right side, which is bringing 2 hydrogen atoms on the right side, we need to add hydrogen atoms on the left side as well. And how many? 2. Now here is what the common mistake is happening. We cannot simply add hydrogen atoms. Now hydrogen atoms is balanced by adding hydrogen ion. Alright, now please do not forget about putting the charge on top right corner. Now, 1 chlorine on each side, 3 oxygen on each side, 2 hydrogen on each side, and we move on to the next step is to look at the overall charge on 2 sides of the equation. Now on the right side, which is obviously neutral because neither one of these 2 compounds is having a charge on top. Now have a look at the other one on the left side. We have -1 charge and then 2 units of positive charge. So this side is having a net charge of +1. Now to balance the balance overall on 2 sides, we're simply adding 1 electron on the left. Alright? So this is balanced, the charge is balanced by adding negatively charged electrons. Alright? Now, up to this stage, again, have a look at overall properties of the thing. 1 chlorine, 3 oxygen, 2 hydrogen, and then -1 plus -1 is -2 plus +2, that's 0. 0 charge on the left, 0 charge on the right. Now this half equation is already balanced. Now moving on to the other half equation. Now we're having the other reactant, which is a chlorine ion. We are having ClO2. As we have said before, okay, some compounds are coming out of reduction process, some are coming out of oxidation process. Just luckily, we're having the 2 results being the same compound, and that's the reason why we have only 1 compound sitting on the right side of the equation. And then, alright, we have to go through these steps again. The element other than H and O is the chlorine. Chlorine, 1 here and 1 over there, already balanced. There's no need to fix any numbers at all. And then O, oxygen. By adding H2O, we have 2 oxygen atoms on the right side. On the left side, we don't have any. So we can balance that by adding 2 water molecules. Now this is how to balance the number of oxygen atoms. And then, alright, we're going to balance the number of H on 2 sides. We're having, how many H do we have here? We have 2 water molecules. In each water molecule, we're having 2 hydrogen atoms. Now what it means is we have 2 people. Each person has 2 kidneys. How many kidneys do we have in total? 4. Which means on the other side, we need 4 hydrogen atoms or ions. Yeah, we need ions at this stage. Now check again. 1 chlorine, 2 oxygen, 4 kidneys, 4 hydrogen atoms, and then the next step is to look at the overall charge. The charge on the left side is -1. Now only chlorine is negatively charged, water is neutral. On the right side we have 0 neutral charged, 4 positive charge, so this guy is having +4. The number for the overall charge. Now apparently that side is more positive, so I'm going to add electrons on the right side to balance it off. Right, now if you are wondering why I'm adding 5 electrons on the right side, and you cannot figure this out, I would suggest you come to Golden Key for some math help. Right, before we add 2 half equations together, we have 1 chlorine, 2 oxygen, 4 H, negative 1 overall charge on either side. Right. Up to this stage, we're going to add the 2 equations, okay? But the clue is, before we're adding the 2 equations together, LCM, the number of E's. Right. LCM stands for lowest common multiple. We have 1 electron sitting on top, we got 5 electrons at the bottom. What we're going to do to make sure that the electrons are having the same number, simply multiply the top equation all together by 5. Right. Now be careful. This 5 is multiplied to the whole equation, which means this 5 is applied to all compounds, or let's say free elements involved in this reaction. All right. Now let's look at how we add these things together. Now to show this more clearly, I'm using a different color. Okay. Now let's do this step by step. The top equation on the left side, we have 5 ClO3 negative 1 charge. We're having 10 hydrogen ion. We're having 5E. We're having 1 Cl, we have 1 chlorine ion. We're having 2 water molecules. This is on the left side of the 2 equations. Now on the right side of 2 equations, we're having ClO2, and then we have water. Now, have we missed? As we said before, this 5 should apply to every single element, which means every single atom, across the whole reaction. Apparently, we should have 5 multiplied in front of this compound, and 5 applied to the water from the first equation as well. And then the second half equation, we're having ClO2. All right, nothing multiplied in front of it. All right, leave it alone. And then we're having 4H. And then we're having 5A. All right. Now, if you can recall what we have said at the very beginning, after we have added 2 half equations together into one super big equation, we got to do some steps of simplification. Now, how do I do simplification? First of all, cancel out the common things on 2 sides. Apparently, the 5 E's are cancelled out. Because the number of charges is something we have used as a clue. We have lowest common multiple about this E. Apparently, we should have the same number of electrons, right? Cancel it out. And the second we can cancel out is water. We have 2 water here. We have 5 water here. And then cancel 2 molecules of water. We're having 3 water left on the right side of the equation. Now, what else can we cancel? We have noticed there are 10 hydrogen ions on the left side. We have 4 hydrogen ions on the right side. And then apparently cancel 4 hydrogen ions. We're having 6 left on the left side because the left side has 6 more hydrogen ions than the right side. Now, finally, let's have a look at the overall equation, okay? So 5 ClO3, and then we have 6 hydrogen ions. We're having 1 chlorine ion. All right, water has disappeared, don't worry about it anymore. And on the other side, we're having 5 chlorine O2. We're having 3 H2O. We're having ClO2. Now, apparently what we have found is these 2 compounds, they are same. Now, if we look at the type of compound, they are same, right? But 5ClO2, it appears in the first reaction, and then this comes out of the second reaction. Now, we have 2 different types of chemical reactions. One of them is oxidation, the other one is reduction. Which means one of them comes from the reduction, the other comes from the oxidation. Now finally, because these two guys are same, we would have to combine them, just like combining like terms when you're doing math. Alright, so 6 altogether. Right, let's double check. We should have 5 chlorine plus 1 chlorine, 6 chlorine atoms. 6 chlorine atoms. Balanced, tick. 6H, 3 water molecules. Each water molecule has 2H. 6H over there as well. Alright, tick. How many oxygen do we have? 5 times by 3, 15 in total. And on the right side, 6 times by 2 is 12. 12 plus 3 is 15. We have 15 oxygen atoms on 2 sides, balanced. Finally, what do we still need to check? Alright, the charge. We have 5 negative charge, 6 positive charge, and 1 more negative charge, which means overall it should be 0, it should be neutral. On the right side, yes, it is neutral. Right? Okay. Now, there's one more thing we need to double check as well, which is not implied by the 2 half equations, but implied by the question. In the bracket it says, in acidic solution, which means in water solution there's excessive hydrogen ions available in the solution. This is showing it's acidic. Alright? Because we need 6 moles of hydrogen ions to promote this redox reaction. Alright? So this is just a sign or a piece of evidence to support the idea that this reaction happens in acidic solution. Alright? Now so far we have introduced, we have discussed through the steps we need to take to balance a redox reaction in terms of how to separate into half equations and the order of dealing with compounds in this order. Alright? And we also have discuss the strategy we use to balance the hydrogen, how to balance the oxygen, and how to balance the overall charge. Now, hopefully this video is going to be helpful to your